A and B are two bars linked by 1/6 meters long rope, and they are thrown horizontally at the speed of 4.5 meters per second, 1 by 1, 0.8 second intervals. So the question is that how much later the rope will be pulled tight. At the horizontal direction, we can draw a graph like this to show the delta x. Because x equal to velocity plus time, so delta x equal to xa minus xb, and is equal to velocity plus delta x. So the result is 3.6 meters. We can also draw a graph at the vertical direction to show delta y. Suppose time equal to t, so this formula tells us what is y, and the delta y equal to ya minus yb. So it is the formula like this. So to calculate this, we can put it in the calculator. They show that the result is this. So it's this. Finally, in this triangle, we found that the 6 square equal to delta x squared plus delta y squared. So there is this in the calculator. Obviously, t cannot be the negative number, so the result is t equal to 1. Progresses 1, 2, 3. Yay, result, bingo! A projectile is shot from the edge of a cliff 125 meters above the ground level with an initial speed of 65 meters per second at an angle of 37 with the horizontal. The first question is that, what is the time taken by the projectile to hit the point P at the ground level? The second is determine the range x of the projectile as measured from the base of the cliff at instance just before the projectile hits point P. To solve what time equals to, first of all, we can draw a triangle to separate the velocity to velocity y and velocity x. The velocity y equals to tangent 37 plus 65 meters per second is equal to this. And we suppose time equals to t, so we got an equation like this. To put the value inside, we can solve the result. It is this. So our time equals to 12.1 seconds. So the range, we can also draw a right triangle to separate the velocity. This time we want to value the velocity x. It is equal to cosine 37 plus 65 meters per second, so the value is shown like this. And next, we can use this formula to solve the x. So x equals to 628.11 meters per second. So the result is this. A passenger on a boat moving at 1.5 meters per second on a steel lake walks a flight of stairs at a speed of 0.5 meters per second. The stairs are angled at 45 points in the direction of motion as shown. What is the velocity of the passenger relative to the water? To solve this question, firstly, we can draw a graph. This shows the human's velocity and this is the boat's velocity. And we can translate to this. So this is the velocity we need to calculate. Firstly, we should calculate what is A. A equal to this. So it is sine 45 plus 0.5 meters per second. It is equal to this value. And the B equal to A plus VB. This equals to this because this angle equals to this angle, so this equals to this. So you can calculate like this. So the velocity we need to calculate is this 1.887 meter per second. The result is this. Question is that a human walks at the speed of 0.6 meter per second across his raft, and the raft is traveling down the Mississippi River at the speed of 1.7 meter per second relative to the river bend. So what is the human's velocity? We can first to draw a graph. This is the velocity of human, 0.6 meter per second, and this is the velocity of the river, 1.7 meter per second. This is a right angle. So the velocity equals to this, the square root of 0.6 square plus 1.7 square. It is 1.8 meter per second. If we want to know the direction, we have to calculate what theta equals to. Theta equals to tangent negative 1 plus 1.7 meter per second over 0.6 meter per second. It equals to 70.55 degrees. 1.8 meter per second, 70.56 degrees east of north. Yay!